Are we alone in the universe? This is a question humans have asked for centuries. We look up at the night sky, we see countless stars. Each star could be a sun to other planets. Many of those planets could hold life. Some might even have civilizations far older than ours. Yet when we listen for signals, when we search for any sign, we find silence. This brings us to something called the Fermi Paradox. It's named after the brilliant physicist Enrico Fermi. One day, back in 1950, Fermi was having lunch with colleagues. They were talking about aliens and flying saucers. Fermi suddenly asked a simple, yet powerful question. Where is everybody? Our galaxy, the Milky Way, has hundreds of billions of stars. Many of these stars likely have planets. If even a tiny fraction of those planets develop life and then intelligent life, there should be many civilizations out there. If these advanced civilizations exist, why haven't we seen any evidence of them? No probes, no signals, no giant space structures. It's a paradox because the high probability of alien existence clashes sharply with the total lack of observed evidence. The universe is incredibly old, about 13.8 billion years. Our solar system is younger, around 4.5 billion years old. Where are they? Why haven't they made their presence known? One intriguing idea to explain the Great Silence is called the Great Filter. Imagine life, from its very first spark to a galaxy-spanning civilization, has to pass through a series of challenging steps. Think of it like an incredibly difficult obstacle course. Many try to complete it, but very few succeed. The Great Filter is a hypothetical barrier, a point in this developmental journey so hard to overcome that it stops most, if not all, life from progressing further. This filter could be something that makes it very hard for life to start at all. Or it could be a challenge that prevents simple life from becoming complex. The crucial question about this great filter is, where does it lie in our timeline? Is it behind us, or is it still ahead of us? If the great filter is in our past, it means we humans are incredibly lucky. We have somehow passed a major hurdle that most other potential life forms in the universe did not. However, there's a more sobering possibility. What if the great filter is still ahead of us? This would mean that life and even intelligence might be common throughout the universe, but something prevents these intelligent species from reaching a stage where they can communicate or travel across stars. This something could be a self-destructive tendency. If the filter is ahead, it's a warning for humanity. Understanding the great filter is not just about aliens, it's about understanding our own past and, more importantly, our potential future in this vast universe. Another way to think about the Fermi Paradox is to consider that life itself might be common, but intelligent life, the kind that builds radio telescopes and spaceships, could be incredibly rare. The universe is vast, and the basic building blocks of life, like carbon, hydrogen, and oxygen, are everywhere. So it's plausible that simple, microbial life could be widespread on many planets. Think of little alien microbes swimming in alien oceans. That might be a common sight across the cosmos. But going from a single-celled organism to a thinking, tool-using being is a giant leap. A truly enormous one. On Earth, life existed for billions of years before humans appeared. For most of that time, life was simple. Dinosaurs roamed the Earth for 165 million years, but they didn't build cities or ponder the stars. Intelligence, as we know it, with complex language, abstract thought, and advanced technology, is a very specific adaptation. It might be a fluke, a lucky accident in our evolutionary history. Perhaps the precise sequence of events that led to human intelligence, the right-sized planet, a stable star, a large moon, plate tectonics, specific evolutionary pressures, is so unique that it has rarely, if ever, happened elsewhere. Consider the sheer number of species that have ever lived on Earth, millions upon millions. Yet only one, Homo sapiens, developed the kind of intelligence that allows for advanced technology and space exploration. This suggests that high intelligence isn't an inevitable outcome of evolution. If there are countless planets with life, but only a tiny fraction develop intelligence, then the galaxy could be teeming with plants and animals, but very few civilizations capable of interstellar communication. This idea is sometimes called the rare Earth hypothesis in a broader sense, or more specifically, the rare intelligence hypothesis. Our existence, then, would be an extraordinary cosmic treasure. Section 4. The Hurdles of Galactic Communication. Even if intelligent alien civilizations exist, communicating across the vast distances of space is a monumental challenge. Space is big, really, really big. Our closest star, Proxima Centauri, is over 4 light-years away. That means light, the fastest thing in the universe, takes 4 years to travel from there to here. If we sent a message to a planet around Proxima Centauri, and they replied immediately, we would have to wait 8 years for an answer. That's for our very closest stellar neighbor. Most stars in our galaxy are thousands or tens of thousands of light years away. Imagine trying to have a conversation where each reply takes decades, centuries, or even millennia. It's not exactly a snappy chat. This makes sustained communication incredibly difficult. Furthermore, what kind of signal would we even look for? We mostly search for radio waves because they travel at the speed of light and can pass through gas and dust in space. But would an advanced alien civilization use radio? They might have moved on to communication technologies we can't even imagine, like neutrino beams or gravitational waves or something completely beyond our current physics. Then there's the problem of timing and direction. A civilization might only transmit signals for a certain period of its history. Perhaps they broadcast for a few thousand years and then go quiet, or switch to a different technology. If their broadcasting phase doesn't overlap with our listening phase, we'd miss them. We also have to point our telescopes in the right direction at the right time to catch a fleeting signal. The technological hurdles are immense. Section 5, The Silent Neighbors, Why Aliens Might Choose Not to Call. Let's explore another possibility. What if advanced alien civilizations are out there, but they are deliberately choosing not to contact us? This might sound like science fiction, but there are some plausible reasons why they might stay silent. One idea is the zoo hypothesis. Imagine we are like animals in a cosmic zoo or a wildlife preserve. The aliens are the zookeepers, observing us from a distance. They might want to let us develop naturally without interference. Contact could disrupt our society, our culture, our entire development, perhaps in harmful ways. So they watch, but they don't touch. Another related idea is the prime directive concept, popularized by Star Trek. Advanced civilizations might have a strict ethical code that forbids them from interfering with less developed civilizations like ours. They might believe that contact should only happen when a species reaches a certain level of technological or social maturity. Perhaps they are waiting for us to solve our own problems, like war and environmental destruction, before they decide to say hello. It's also possible that aliens are simply not interested in us. An incredibly advanced civilization millions of years ahead of us might find us as uninteresting as we find ants on the sidewalk. Their concerns, their science, their philosophy might be so different from ours that communication would be pointless or impossible. Or perhaps they are aware of us, but they have learned from past experiences that contacting other species is dangerous. Finally, there's a more unsettling thought. What if the galaxy contains predator civilizations? Section 6. The immensity of it all, lost in the cosmic ocean. The sheer scale of the universe is something that is hard for our human minds to truly grasp, and it plays a huge role in the Fermi Paradox. Our Milky Way galaxy alone is about 100,000 light-years across. That means if you could travel at the speed of light, it would take you 100,000 years to go from one end to the other. And the Milky Way is just one of an estimated 2 trillion galaxies in the observable universe. Each of those galaxies contains billions, sometimes hundreds of billions, of stars. The numbers are staggering, almost beyond comprehension. Think about trying to find a specific person in your own city without knowing their address or phone number. It would be difficult. Now imagine trying to find another intelligent species somewhere within our galaxy, which is vastly larger and mostly empty space. Even if there are thousands of civilizations out there, they could be spread so far apart that the chances of us stumbling upon one, or them stumbling upon us, are incredibly small. Moreover, we are not just separated by vast distances in space, but also potentially by vast gulfs in time. A civilization might have risen, flourished, and then vanished millions of years before life on Earth even became multicellular. Or perhaps future civilizations will emerge long after ours is gone. The universe has been around for nearly 14 billion years. Human civilization, with its technology, has only existed for a tiny sliver of that time. The window of opportunity for two civilizations to exist simultaneously and be close enough to detect each other might be very narrow. Section 7. Listening to the Stars. Our Ongoing Quest and Future Hopes. Despite the silence and the daunting challenges, humanity hasn't given up the search for extraterrestrial intelligence. Organizations like SETI, which stands for the Search for Extraterrestrial Intelligence, have been listening for decades. They use powerful radio telescopes to scan the skies, hoping to pick up an artificial signal from a distant star system. It's a patient vigil, a long-term commitment to answering that fundamental question. Are we alone? The search is constantly evolving as our technology improves, allowing us to scan more stars, more frequencies, and with greater sensitivity. New telescopes, both on the ground and in space, are coming online with capabilities far beyond what we had before. The James Webb Space Telescope, for example, can study the atmospheres of exoplanets, planets orbiting other stars. While it's not directly looking for alien signals, it could find biosignatures, chemical signs of life like oxygen or methane, in an exoplanet's atmosphere. Finding such signs wouldn't confirm intelligent life, but it would tell us that life itself is not unique to Earth. This would be a monumental discovery and would surely intensify the search for intelligence. The future of the search might also involve looking for different kinds of evidence. Some scientists propose looking for technosignatures beyond radio signals. These could be things like massive artificial structures, often called megastructures, built by advanced civilizations. Think of a Dyson sphere, a hypothetical structure built around a star to capture its energy. Or we might look for signs of industrial pollution in an exoplanet's atmosphere, or unusual patterns of light that could indicate artificial illumination on a planet's night side. The possibilities are as varied as our imagination. Ultimately, the quest to find alien life is a profound human endeavor. It drives scientific discovery and technological innovation. Whether we find aliens tomorrow or 1,000 years from now or never, the search itself teaches us about the cosmos and about ourselves.